Hello everyone, my name is Ruman. I am a PhD student of Dr. Wei Long Fong. Today I will show you how to do photolithography in our lab. So in our lab, we have the facility for doing photolithography. And this particular machine is the photolithography machine. The name is Microwriter ML3. There are a few steps for photolithography like spin coating, then soft bake, then photolithography, then development, etc. Before discussing all the steps, let me turn on this particular machine because it takes about 10 minutes to start this machine, 10 to 15 minutes. So this is the switch. I will turn on the switch. When I turn on the switch, I can see that red light is flashing. So when the red light stops flashing, I can start the software for this machine. Okay, this is the computer that is connected to this particular machine. So maybe after 10 seconds or so, I can see that this red light will stop flashing. Let's wait for a few seconds. Okay, so it stopped flashing. Now I can open the software of this Microwriter ML3. The software is also MW3. I will just start this application. It takes about 10 to 20 minutes to start the whole software, okay? Because there are some parts inside this machine that needs to be placed in the right position. Okay, let me explain what I am going to do today. So, photolithography. There are a few steps. At first, we need to prepare the substrate. Today I am going to use silicon wafer. 4-inch diameter silicon wafer will be used for today's demonstration. So we need to clean the surface. The silicon substrate should be cleaned at first, and generally it is cleaned by piranha solution. Piranha solution is actually a combination of a mixture of sulfuric acid and perchloric acid, but in our lab we don't use the piranha solution. We use acetone. At first we clean the silicon wafer with acetone, then we clean the silicon wafer with isopropyl alcohol or IPA, then we clean that again with DI water or deionized water. After that we need to make it dry. Okay, so for that we have a air blower. So we use that air blower or nitrogen blower to dry the silicon wafer. Okay, the purpose is we don't want any water droplet or any IPA or any acetone on top of the silicon wafer because that will contaminate the whole wafer. Okay, let me tell you, this particular lab is not a clean room. Okay, we are not able to do anything at nano level. There are so many dust in our lab, and also I am just wearing these gloves. I am not wearing any protective gown, or I am not wearing any mask, so there might be some contamination from my body also. I am just wearing these safety goggles and these gloves. Okay, so we are not going to do anything at high end. We are not going to go at nano level photolithography. We are going to we will do something at micro level because this machine is low end Microwriter, micro. It can do at micro level. So after preparing that substrate, that is after cleaning with acetone, IPA, DI water, drying with air, high speed air, we will use this spin coater to spin coat the photoresist on top of the silicon wafer. Okay. Now there are so many types of photoresists. Photoresists are different types of are actually chemicals. Okay. There are SQ10, SQ50, SU8, SU1818, etc. Different types of photoresists for different types of substrate, for different types of application. Today we will use the SQ10 photoresists, and there is a manual for this particular photoresist. There is a protocol that we need to follow. We should check the website of the company. They have their own set of protocols that we need to follow. For example, I am using SQ10 today. So for SQ10, I need to spin coat with 2000 RPM at for 30 seconds or something like that. I need to do, after the spin coating, I need to do the soft bake. So soft bake is after the spin coating is done, I will place that silicon wafer with photoresist on a hot plate, and it will be done, the protocol says it should be done, it should be kept on top of hot plate for 2 minutes at 65 degrees Celsius, and after that for 5 minutes at 95 degrees Celsius. After the soft bake, actually we can do the photolithography here in this particular machine. After the photolithography, we will do the bake again, which is called post-exposure bake. And for this particular photoresist, the protocol says the post-exposure bake should be done for about 5 to 7 minutes at 95 degrees Celsius or something like that. After that, we will do the development with developer. So SQ10 has a particular developer that we need to use, and after the developer works, we will see that some of the photoresists are done, and we will see our design there. Now about this machine, when we are going to do the photolithography, actually we need some particular design, we need some particular pattern. How can we do that? We can easily do that using Inventor software, we can do that with AutoCAD software, we can do with SolidWorks, we can do with K-Layout. So the file format is, I think, CIF or something like that. We need to convert the design into that particular format, and after that we will be able to use that particular pattern for our photolithography. Now the beauty of this particular machine is, this is a maskless photolithography machine. That means we don't need the photo mask for photolithography. Generally, when we do the photolithography, generally people need the photo mask because they will make the design, they will make the pattern, they will generally we send it to some other companies who make the photo mask for us, and we use the photo mask on top of the silicon wafer, and then we expose it under the UV light. Now here we don't need the photo mask because this one, it will actually, the UV light will be exposed according to my design. Suppose if I do the design in S shape or in A letter shape or something like that, the UV light will be exposed according to that. Okay, just maybe A or B. It will not be exposed on the whole surface. Okay, so this is the beauty of this particular machine. We don't need the photo mask. We will just do the design. We will make the pattern using some software, and we will use this particular software, and this machine will expose the UV light according to our design. So this is maskless photolithography. Now after the development, what I said before, after the development, we will see that the photoresist, most of the photoresists are done, and we will see the pattern on top of the silicon wafer. So this is the end of photolithography, but if we want to etch some materials, then we can do the etching, and for etching we use different types of etchant. For silicon, silicon dioxide, chromium or some other material, we need to use particular type of etchant. For example, chromium has chromium etchant, silicon has silicon etchant. So etching agent or etchant are also chemicals that are particularly made for that particular material. Okay. Now let me start the photolithography, and I will start with the cleaning of silicon wafer. Okay, so actually I already cleaned the silicon wafer. This is my silicon wafer. What I did, I used the acetone at first. I used this acetone to clean the dirt from this silicon wafer. Then I used the IPA or isopropyl alcohol. Then I used the deionized water or DI water to remove the acetone and IPA from the surface of this silicon wafer. Okay, so you can see this is the silicon wafer. This is very shiny. This polished surface will be used mainly, and this surface is actually not smooth. So this is the back end, this is the front end. Okay, so after this cleaning process, there might be some water on top of the surface, and what we will do, we will use the air pressure to remove all the water droplets from the surface. I'm going to show you that now. So here we have air. I will start. We can hear some sound, and I can easily remove the water droplet using this air pressure. Now I will show you the spin coater machine. Okay, so this is the spin coater machine. I will remove the cover. This is the holder. Okay, there are different sizes of holders. Different sizes is used for different sizes of wafer. So I will place the silicon wafer on top of this holder, and actually it holds this wafer with vacuum pressure. Okay, we need to carefully place it in such a way that it is right at the middle of that holder. So I will turn on the power button, then I will turn on the vacuum pump. So it will make some sound. Let me tell you, I will turn on the vacuum pump. It will hold the silicon wafer, and you see the speed is already set here. So the final speed should be 2000 rpm. This is 200 here. 200 times 10, that is 2000 rpm for 30 seconds. What we do generally, we don't go to that high speed at once. We initiate the speed with some low speed like 30 times 10, 300 rpm for 10 seconds, then 2000 rpm for 30 seconds. So I will cover it with the lid, then I will turn on the vacuum pump, then I will start the spin coating. Okay, so before spin coating, we need to place the photoresist. Okay, we need to drop some amount of photoresist on top of the silicon wafer. Then that photoresist will be spin coated and it will be uniform. So we need uniform thickness, right? So let me show you. Here in this cabinet we have some chemicals. We have different types of photoresist. So for our today's demonstration, we will use this one, which is SQ10. So SQ10, I poured some amount of SQ10 on top of the silicon wafer. Then I will place the lid the cover, then vacuum pump on and start. We can see the spinning of the silicon wafer. Okay, after the spin coating is done, we will see that I have already turned off the vacuum pump. So after that we will see that a uniform layer of photoresist has been deposited on top of the silicon wafer. Okay, next step is soft bake. Soft bake is done here. The temperature is initially 65 degrees Celsius. For 2 minutes. The temperature is now at 27. It will automatically go up to 65 degrees Celsius. Okay, so the temperature is set at 65 now, and I will use a stopwatch. It will be soft bake at 65 degrees Celsius for 2 minutes. So after 2 minutes, I will increase the temperature up to 95 degrees Celsius. And then we will hold it for 5 seconds. It will take some time to raise the temperature from 65 to 95. When it is at 95, after that we will wait for 5 minutes. So next step is photolithography. After the soft bake is done, we will take this silicon wafer and we'll come here. This is the Microwriter machine. This is the software. I will press this button, and after a few seconds I can actually open this gate. I will place this silicon wafer. You see the flashing is off. Now I can take this, let me show you from here. I will open the gate and I will place this inside this chamber. So you see the silicon wafer is at the middle. Actually, we can place larger size of wafers here also. After that, I will press this button again. It will close this lid, and there is a Z direction stage which exposes the UV light that came into the right position. So after that, I will come back to this computer, and here there are 3 steps. One is, you see my cursor here, align wafer, prepare pattern, and expose. So at first, align wafer, I need to click here microscope and click here focus assist. So it will take a few seconds to focus the actual plane. I may need to input the wafer thickness here, so the input maybe 500 micron. The wafer thickness. This is the autofocus. I clicked here and I will wait for few seconds. So after focusing, we will say we'll see some black and white boxes like check box here. So it takes a few minutes generally to autofocus the actual surface where we are going to expose the UV light. After the focusing, we will go to this prepare pattern. We will add a job here, add a new job, click here, and we need to select the design, the pattern, okay? So maybe I will use this one. I have selected the file. It will take a few seconds to show it here. Now you can see the design. So the design is actually like this. There are some microstructures. These are 8 by 10 micron circles. So 8 is the diameter, the 10 is the distance between the circles. So after this step, we will go to the expose, and we will write down the energy. So the photoresist sensitivity is in millijoule per centimeter square. So according to the guideline or the protocol of the photoresist, it's written 270 millijoule per centimeter square for our photoresist. So I have written 270 here, and this is the start exposure. I clicked here now, and then after clicking this exposure, it takes a few minutes or a few seconds to finish the photolithography. So the UV light will be exposed, and it will be exposed according to my design. Okay, so after a few seconds, it has stopped exposing that UV light. So what I can do now, I can just open this lid. I click this button again, and then after a few seconds I will hear a click sound. Then I will be able to open this gate, there is a click sound. I can open the gate, and let me take that out. I closed it. So now this silicon wafer has been exposed to UV light according to my pattern. So I want to close this application, and I want to turn off this machine. So at first I need to close this application, close this software. So just close it, and after that I will turn off the switch. So now I will take this wafer again to the hot plate. So it will be baked now, which is called post exposure bake. It will be baked now again for 2 minutes at 65 degrees Celsius and for 7 minutes at 95 degrees Celsius. So what I will do, I will just set the temperature and do the similar kind of things. So this baking is called post exposure bake. After the post exposure bake, we can take this silicon wafer, and what we will do, we will develop it. Okay, so develop is done with help of a developer. So developer, I'm not going to show that step because it takes a long time. So the develop is done in a bath, like maybe in this bowl, or we have some petri dishes. We will keep this silicon wafer there in that petri dish, and we will submerge it with the developer, and then we will rinse it, and we will actually shake this so that the developer can strip out the photoresist as per the design, as per the pattern. Okay, so after that development, we will again bake that on the hot plate. So that is known as hard bake. So after the hard bake, photolithography is done. Okay, now if someone wants to etch out the material like the silicon or silicon dioxide or maybe chromium or something like that, so they will use chromium etchant or silicon etchant or silicon dioxide etchant or etching agent or something like this. Okay, so this is photolithography. What we did first, we cleaned the silicon wafer, we cleaned it with acetone, we cleaned it with isopropyl alcohol, distilled water, we made it dry with help of pressurized air. Then we did the spin coating of the silicon wafer with the photoresist, then soft bake, then photolithography, then post exposure bake, then development, then hard bake, and that's it. So as I said before, in our lab we can do microfabrication, not nanofabrication. So this is a sample, or this is a microfluidic device. More precisely, I should say, this is a digital microfluidic device that we have made with the help of photolithography. So here you can see the pattern. This is actually a glass slide, and the black materials are actually chromium. Okay, so we designed a photo mask, or we designed the mask like this. Then we did the UV exposure under the photolithography machine, and after the development we got something like this. So this is actually a digital microfluidic device. After this I will just add a video where I will show how I use this digital microfluidic device for transportation of water droplet from one area to another area. Okay, so that's it. Thank you all for watching this demonstration. Bye.